Hi everyone, hi there. Today I am going to discuss 2016 advanced level question. Why the rotational motion part being the inertia in different level, different dimension, including some question related to merry-go-round. Because this includes the theories, you can understand everything in there. This is the best video, so watch it till the end. God bless you.
Okay, let me analyze the question 2016 A-level rotational motion question. Let me read it out now. A particle of mass m1 and fixed to a rim of horizontal ring of radius simple r negligible mass as shown in the figure 1. P or Q is a vertical axis passing through the center of the ring.
The part A, question number 1. Now let me read it out and write down an expression for the moment of inertia I1 of a particle about vertical axis P or Q in terms of M1 and R1. Is moment of inertia for an object revolving around a circular path. It contains certain property called moment of inertia. You may already know what is it or you may don't know. So I decided to give you a theoretical review, quick review. Just watch this animation and understand. Now if you consider one single revolution like this, just see this one. Before going for the moment of inertia, you have to remember what is just linear moment of inertia. It is something just reluctance to change the position of motion. An object which is in rest is just like to stay rest, or that is keep moving, it just keep moving. That is the basic theory of moment of inertia. And for the revolving objects, they don't like to stop the motion or just gain the motion if they are not just about to move. That is the basic concepts. Now you have seen those things. You are trying to push a car or something like a table. Just see the animation. It is like to push the thing hard because it doesn't land. Simplified equation E for the rotational inertia is capital I is equal to simple mr square. That is the equation for moment of inertia. You may find for few masses all together, not a single mass. It is something like I is equal to sigma mr square. You will immediately learn this in a question. In this paper itself, it gives you the basic idea about how to get this additional of all the inertia together. Let's see, go back to the question and you will see, and you will also derive, and I will guide you to do that. For the first one, so part A, question number 1, A is like I1 uncle is going to be M1 R square, really simple, it's going to be. Now another particle M2, let me read it out for you. M2 is fixed to the rim in the ring other, which is diametrically opposite. That means in the opposite side, and the system is rotated about the P or Q with the constant angular speed omega. If the I2 is the moment of inertia of M2 of P or Q, write down an expression for the total kinetic energy of the system. Before that, I am going to show you what is kinetic energy. Now see, this mass is just going to revolve around. It's really simply going to revolve around the path. As you see, object has a certain tangential velocity, as you see that along the path, as you can see in the diagram. There is a velocity for an object, moving object. What does it contain? You know, there's a tangential velocity. However, there's a velocity, then there's a kinetic energy. How to find out the kinetic energy? It's really easy. Half mv square is the equation to find out the kinetic energy part of this tangential velocity. You know, it's really easy. Now rocket science, there when v is equals to r omega, so you can plug the equation to there. Ek is equals to half mr or bracket omega resolving is equals half mr squared omega squared. In the bracket mr square is nothing other than capital I inertia, so the equation is going to be equals to half I omega squared. This is the basic equation for a system of few particles together. It's going to be total energy is E1 plus E2 plus E3, so that I1 omega square, I2 omega square, because omega is a common thing. It is not omega 1 or 2, it's same omega. Something you have to remember for a system, it is always the same moment of inertia for all the particles. I have already written these things. Let's go for the analysis now. M1 and M2 are typically opposite in the opposite side and the radius, and this one provides some I2 point and this one I1, the omega around P or Q axis. So you can write it like what? Half I1 omega square, omega is common for both because it's fixed to the same frame, half I2 omega square. So I can write it like in that way. So the total system. So the next thing, that is the question number what? 3. This is the answer for the question number 3. Before that, just come back to here. So in this one, it is saying like, if the represents the total moment of inertia of the system A about the axis P or Q using the expression of 10 in part A, so that I naught is equals to I1 plus I2. So we can write it like this way: half I, this is the total kinetic energy for two objects separately and you added them together. If you consider these two objects as just one single system, so the I naught of the system is I naught and half I naught omega square. So you just can simply cancel out half from each, and omega is common as well, omega to omega. So the final result is going to be what? I naught is equals I1 plus I2. Simple. Okay, isn't it? Now let's move to the next question. It's already ready-made done. So instead of M1 and M2, 10 identical masses each of mass M are now fixed on the rim in the ring equals to the spacing I is the moment of inertia of the particle about the vertical axis P or Q. Write down an expression for the total moment of inertia it is for the system about the vertical axis P or Q. So each particle is just revolving around this point. Now I total is what? I1 plus I2 plus I3 plus I10. So you can write it like mr1 squared. So again mr m1 m2 r squared, m3 r squared, mn r squared. So same mass and the same radius. So you have 10 things. So you have to write 10 mr square. Mr square is nothing other than I. So the I total is 10I. Really very simple, nothing else. Just can't repeat the video if you don't understand. Now the very next thing, it's a really difficult, complicated thing as it may look, but it is not actually. It's a really simple thing because the thing is really simple. Now the ring described in V is fixed to an axle and of negligible moment of inertia and coinciding with the vertical axis P or Q using the symmetrically spark negligible mass, and the vertical axis P or Q, this thing using figure 2, the system is often started rotating at rest and the t equals 0 equals 0, and the horizontal plane about P or Q with a constant angular acceleration alpha and reach to a constant angle. Simply accelerate and accelerate. Now it's just going to keep moving at the constant acceleration of the comet, and obtain an expression for the time taken for the system to reach the constant angular speed. Before this, let me remind you the basic theory behind this. If an object is starting to move from t equals 0 and with an acceleration, it's like moving an object with like acceleration in the same way, you start slowly and repeat faster. That is how it is going to be. Now it's at the red color because radiating now. Omega equals 0 and to some omega at time t, you have some basic equations like these ones. Omega equals omega naught plus alpha t, like the same way. Theta is equals omega naught t plus alpha t square, and the other one is omega is theta is the total angle is going to be omega naught plus omega divided by 2 times t, and the omega square is equals omega naught square plus 2 alpha theta. If you have any difficulty in remembering these things, its correspondence linear motion equations are like this: v is equals to u plus at. Isn't that similar? And this is like distance is equals ut plus half at square. This is like distance is equals, sorry, let me take another different color. Distance is equals to u plus v over 2 times t. And for this one, it is like v square equals u square plus 2as, and they similar. Then it's like this simple, very simple. So omega at the beginning omega is equals 0, omega final omega equals omega naught plus alpha t. The omega you need to get, so start from 0 and sorry, no need to write, plus alpha. Alpha is just alpha, and the t, so the t is going to be nothing other than omega over alpha. Very simple for the first one. Now for the second question, how many revolutions may have been made by the system when it's reached to constant speed omega? Again we have to go for theory, some theory. Now have a good look at this one. Is starting to move from here to complete one cycle. So how as theta equals to 0, and after completing one cycle the theta is equal to some theta value we don't know. But we know one thing, s equals to r theta from basic equations. S is the arc length and the r is the radius and the theta is the what, the angle revolution. So it is like, so for this one s equals to c for this one. Why cent? Because why? Along circumference. Circumference is the distance, so s equal to c, and you can easily find out the c circumference is equals to pi r. Equation number 2. So equation number 1 equals to equation number 2. 1 equals to 2. R theta equals to 2 pi r. R and r can be cancelled off. Theta is equals to 2 pi. This is how it came. It is not a very big deal. You have to always remember, for a one cycle it's always 2 pi. So for any theta, any angle, that means multiples of revolutions, 1 or 2 or 3,000 billions, or only a fraction, 0 0.1, 0 0.3, however the theta or any other theta. So the theta is always n times pi. That means the revolution, this given revolution, say half revolution, 0 0.1 revolution, however the theta is equal to n number of revolutions, a fraction of an integer of billions of numbers, by 2 pi for each revolution, each cycle. So the theta dash is the angular revolution, is the n is for the revolution. So the theta, you can convert what theta to revolution by dividing the factor by 2 pi, theta to revolutions, and the revolutions to theta you have to multiply the number of revolutions by 2 pi because each cycle has 2 pi. Now let's go back to the previous one. Okay. How many revolutions would it make? So the revolution made by the system when it reached the constant angular velocity. Let's find it. So you can write it like omega squared is equals to omega naught square plus 2 alpha theta. And after that you have to go for that. So the stuff is going to be really simple. Now total displacement omega naught is going to be 0 as usual. It's going to be cancelled off now. So this stuff is going to be really simple now. Omega is equals to omega square equals to 2 alpha theta. So you just need to get the theta value here out of it. So how many revolutions before that you have to get the theta, to how to get theta omega square over 2 alpha. This is not the final answer yet. You have to convert revolutions, theta to revolution. You have to divide the entire term by 2 pi. Let's come back again. Now you just need to do what? To get the n number of revolutions by dividing stuff by 2 pi. Dividing to get the revolutions, so that n is equals to omega square. That means omega square over 4 pi alpha. Why? Because you multiplied this by 2 pi. The answer is 4 pi alpha. Really simple. Okay, because you have to again you have to show that the n is equals to theta over 2 pi, right? You have to show this and apply to here and get the result. And next one, question number 2. So write down an expression for the centrifugal force F for acting on one particle when it is rotating about the axis POQ with a constant angular speed omega. Let's move to that. So the planets are bound to the sun, like substituting what? The centrifugal path, it is revolving around it, so the stuff is going to be revolving. So somehow it is going to maintain certain force, why it is known as centripetal force. For any object which is in a circular path having a tangential speed of v, you can just get the equation of the centripetal force, that of Fc, and firstly get the AC, centripetal acceleration is equals v squared over r. So you can substitute v equals to r omega. So the equation AC is going to be r omega squared. So the centripetal force can easily be found. Fc can be mv square over r, or Fc can be mr omega square, according to the condition that you have to apply. Okay, now write down an expression for the centrifugal force acting on rotating about the PQ axis. How can I get it? How the heck can we get it? So this is like the omega is the thing given, not the angular speed, so tangential speed. So the Fc you can write like mr omega square. So really simple then. How to get it? The structure of the merry-go-round shown in the figure 3, which is at rest, similar to the fixed structure of the system described in C above. However, instead of the fixed mass is same, the system has 100 chairs occupied by riders and hung by chairs, and the negligible mass, the moment of inertia of the merry-go-round without riders and chair about axis POQ is there. So that means this one, if you don't consider about anything, the frame and the ropes and the things, the axis going to be just this thing. Keep in mind and consider the situation where merry-go-round revolute about the axis POQ constant angular velocity of 12 revolutions per minute, with all the chairs being occupied by riders, and when the merry-go-round rotates, all the chairs are inclined to the vertical axis by the angle theta, and the figures of the situation respective to one rider. Let's go and see that incident. So this is what figure 4, it shows what is the condition. Now come back to here. So the stuff is going to be get angled. Now I'm going to do a demonstration, get some video so you can see it. And in this particular part, they find what is the reason between this change in angle. Why is that? Now I'm going to rotate my charger like this way. See? So always it makes a bank with the angle. See? And it is not a conical pendulum. It's a different case. This is something like that, but little bit different. Let's see how the forces effect in there. Now I have to analyze all the forces. Now what happened, it is nothing other than the stuff is going to get inclined. Firstly it was like here, then as it begins to move, it's going to just get inclined like this way. Why is that? What is the reason behind this? Because there is the force Fc is just outward, actually the centrifugal force, the centrifugal force sin theta is given by the tension. When you just get resolve the tension, this is going to be the alternate angle theta the same, so it's going to be upward as t cos theta, and this side is t sin theta. The work force is going to be mg downward, Fc over there. So this is really simple that you can find it just looking this one. Now we get the result. So use the relevant calculations, and if the riders are mass 70 kg each and the chairs are 20 kg each, calculate the total moment of inertia of the system P or Q. By calculating the moment of inertia, assume that the total mass of the rider and his chair is concentrated as a horizontal distance of 10 meters from the P or Q. See, as I drew it in the previous diagram, it is like so. See, it's like this. So this is revolving around. Now you just need to consider about this length, nothing else. This length, see, from the middle. See? You have to separate it like this way. So distance of 10 meters from the POQ. It's always the 10 meters from POQ. The distance is 10 meters for the object. Don't consider it slanted, but you have to get the stuff from the central axis. So nothing to worry about. Get the central axis. Now 70. So for the one mass, you have to remember I is going to be that 32,000 thing previously plus this new mass, new thing. What are the new things? So the mass of the guy is some 70 kilogram plus the 20 kilogram for the each chair, and how many of those the 10 stuff, that means the yeah 10 of these things, then you get the mass. This is called about the mass. Since you know the I is going to be mr square, so this is the mass, and you have to multiply this by the r square. R is was 10 square. So you get the answer when you substitute all of these, and you can get the answer like 1,022,000 kg m square. Really simple, because this was the, you might be wondering how come this came, because this is the inertia of the system without riders and the seats. So now I just going to add their moment of inertia as well. For one ride is 70, 20 kilogram for the seat. So altogether there are 10 of these things. This is altogether mass, and the r square is the 10 meter square. Very simple, isn't that? Now move to the next one. Now, as I mentioned earlier in the previous question, so the angle is going to be something like this way here. So the stuff is going to be now calculated. Let me calculate it. Mg downward, so the same angle is going to be repeating here. The angle is theta. So what is theta? And this is going to be T tension. This is T cos theta and T sin theta, and this is what Fc, the force, it is nothing other than that. So how to do it? Now you can balance these three equations. Now for the vector diagram, free body diagram, just draw the free body diagram as always. Now don't think about this complicated thing. Now that shit is gone. Nothing to worry about. Now next thing is to get the cross. That means you know some fellow who used to do the crossing. So like him, you have to always perform a remind. So pray for your God always when you find this type of vector result related question. Remember always that our beautiful cricketer some big well. So how to get it? This is the mg, and this is the cos theta, and this is what T sin theta, and this is at Fc. So I can write this one now along. So Fc is equals to T sin theta, number one. And in the next one, Mg is equals to T cos theta, number two. As you know that sin theta over cos theta is equals to tan theta. So I can divide the first one by second one. This is number 1 over 2. So my answer is going to be tan theta is equals to Fc over mg. So my values are really going to be simple now. So and now we're going to substitute the Fc values. Mr omega square over mg. So m and m going to cancel off each other, so nothing to worry about. This equation is simply going to be r omega square over g. Now let me substitute the values. For the values, we have that the r is going to be what? That is 12 pi, 12 times 4 pi, over 60 times square times what? 10 over 10. Why? 12 is the number of revolutions and 2 pi and per minute. So to get it convert seconds, now I get it the angular acceleration like in this way. So you just can get the result as 1.44. So to get the theta, what is it theta? Theta is equals to 1.44 tan inverse. When you get the tan inverse, it is like the result is going to be theta is 55 degree. Really simple. It's going to be really simple. And the very next one, what is the total rotational kinetic energy of the system? Now the potential energy converted to kinetic energy from the law of conservation of mechanical energy. So it's like total kinetic energy of the system is going to be half ET is going to be half I omega square rotational thing. So what is it? So the half and I is going to be what? 122,000 times omega going to be 1.44. Square. So the result is going to be what? 87,840 joules. Really simple. ET